Here we have quantum numbers and electron configurations. This has probably been a more highly anticipated video for chemistry this year, and we are going to be discussing everything that has been covered in chemistry this week. I know it's been a busy week, a lot of information. We just had PSAT testing, so I'm sure some people may be a bit confused, need a little bit of clarification. So I'm going to make this video as interesting and valuable as possible, so all of you guys can do good on the upcoming quiz. So this is the Bohr model. You should know what it does, how it works, what it looks like. We discussed it all of last week. You may have had a quiz earlier this week, Monday, Tuesday, or Wednesday, depending on which teacher you have. And yeah, so these are the shells. In the Bohr model, we have shells or energy levels, which are these rings over here, n equals 1, n equals 2, or n equals 3, around this red circle over here, which is the atom's nucleus, where all the protons and neutrons are stored. Inside these shells, we have subshells. We're going to be representing these subshells with these ovals over here, so you can ignore this little blue guy. And on each energy level, we have one more subshell than the previous one. So as you can see, we have n equals 1, 1 subshell. N equals 2, 2 subshells. N equals 3, 3 subshells. And on n equals 4, we're supposed to have, you guessed it, 4 subshells. And listen to this because this is very important. The first subshell of each energy level is going to be represented by the letter S. The S subshell can have one orbital which contains 2 electrons. So in n equals 1, we have the S subshell, the first one orbital, 2 electrons. N equals 2, we have the first subshell over here, the S subshell, 1 orbital, 2 electrons. But the second subshell over here in n equals 2 will be the P subshell, which can hold 3 orbitals, 6 electrons. So again, the S subshell, 1 orbital, 2 electrons. S subshell, 1 orbital, 2 electrons. P subshell, 3 orbitals, 2 electrons each, 6 electrons total. Again, energy level number 3, S subshell, P subshell, D subshell. This has 5 orbitals, 2 electrons each, 10 electrons total. And in the 4th energy level, we will follow the same pattern. We will have an S subshell, a P subshell, an D subshell, and then an F subshell. This is going to have 7 orbitals, 14 electrons total. So you can see the pattern. It's increasing by odd numbers: 1 orbital, 3 orbitals, 5 orbitals, 7 orbitals, 2 electrons in each. So that was probably the most important concept you guys need to grasp for the Bohr model this week. And as you can see, I have another visual representation of the electrons inside of these subshells. S subshell, 1 orbital, 2 electrons. S subshell, 1 orbital, 2 electrons, this time in the 2nd energy level. Again, in the 2nd energy level, we have the P subshell, 3 orbitals, 2 electrons each, 6 electrons total. And then in this 3rd energy level, we start with the S subshell again, 2 electrons. And since this atom has 12 electrons total, this is magnesium. In the periodic table, all elements are stable, so the amount of electrons should equal the amount of protons. That's how I know this is magnesium. And now we're going to write the electron configuration for magnesium. So we have 2 electrons in the S subshell, 1st energy level, 1s squared. 1st energy level, S subshell, 2 electrons. 2 electrons in the 2nd energy level, S subshell, 2s squared. 6 electrons in the P subshell, still in the 2nd energy level, 2p to the 6. And then finally 2 more electrons in the 3rd energy level, S subshell, 2 electrons, 1s squared, 2s squared, 2p to the 6, 3s squared. That is the electron configuration for magnesium. So this is probably the most important thing you would have to know for Friday's quiz, the electron configuration, and basically these quantum numbers, and how this connects to the periodic table. All of the elements have their own electron configuration, basically the same thing we did for magnesium, which is over here on the periodic table. Basically just follow this pattern. All of these elements have their own number of protons, their own amount of subshells and orbitals, and that's basically how you get electron configurations for the rest of the periodic table. as you can see, it goes all the way up to F, as we stated earlier, has seven subshells. Sorry, 7 orbitals, 2 electrons each. So what do you guys need to know? You guys need to know about the 4 quantum numbers. I didn't discuss this as much, but it does apply to the electron configurations and what we just did. And the orbital shapes by subshell. Each subshell, again, right, has its own letter and its own number of orbitals. And they all have different shapes. So the S subshell will have 1 orbital, 2 electrons in a spherical shape, all the way up to F, which is going to have 7 orbitals, 14 electrons, and a complex shape. Again, ask your teachers for any further clarification. And yeah, I hope you guys understood almost everything that I've discussed already. And we are moving on to our final part of the video. Electron spin and the Pauli exclusion principle. Each orbital can hold 2 electrons with opposite spins. Remember that each electron in the orbital cannot spin the same way. They can have a positive spin or negative spin. No 2 electrons in the same atom can have the same 4 quantum numbers. And then the final principle, the Aufbau principle, electrons fill the lowest energy orbitals first. So you can't fill the p orbital in the second energy level before you fill the s orbital. Sorry, the subshell. You can't fill the p subshell before you fill the s subshell. So I hope this all made sense. We just did orbital diagrams above. That's basically where you have the arrows indicating the spins. And yeah, thank you guys so much for watching the video today. I hope you guys do good in the upcoming quiz. And please support me by subscribing to my YouTube. Shout out to Ian Lee and Josh Yu for this idea to expand my videos on YouTube. Hopefully we can get a few subscribers. I'm not sure, I'm pretty new to this. So yeah, thank you guys so much. Hope you guys do well, and I am signing off.